Good morning, everyone. In this today's video, we are going to discuss about the speed governing mechanism in the topic of power system operation and control. This is one of the main important topic about that how to control the valves that going to give the input to the turbine. First, we are going to discuss about that components of the speed governing system. We have four main components, that is flyball speed governor, speed changer, hydraulic amplifier, and the linkage mechanism. These are the four important components of the speed governing system. Now, one by one, we are going to discuss about that. What is flyball speed governor? What is speed changer? What is hydraulic amplifier? And linkage mechanism. This is the schematic diagram of speed governing mechanism. Here, the four components are speed changer, that is left hand side, that having the two command, lower command and rise command. The next one is speed governor. In the bottom, we have look like two balls, that is speed governor, and hydraulic amplifier. It is parallel to the speed governor. The next one is linkage mechanism. The linkage mechanism is A to B, B to C, C to D, and then D to 4. This is the schematic diagram of speed governing mechanism. Here, the main objective of the speed governing mechanism, we have to open the valve and close the valve, which are going to give the input to the turbine. May consider we have, that is a steam turbine, that is a steam thermal plant. We have to give input to the turbine. The input to the turbine is steam. So from that mechanism, we can easily control the steam and we can easily open the steam and close the steam to the turbine. Now we are going to discuss how to control, how to open, how to close the valves to the turbine. Here in the speed governing mechanism, we have two modes of operation. The first mode of operation is by using the speed changer. Manually we can give the lower command and rise command. The second mode of operation is automatic mode. By sensing the speed of the turbine, the flyball, that is speed governor, going to operate. This is about that speed governing mechanism. Now we are going to discuss about that, how we are going to open the valve, how we are going to close the valve by using the speed changer. Next part, how based upon the turbine speed, now we are going to control the valve by closing and opening by using the speed governor. Here, the operation and command direction. Rise command means downwards, lower command means upward. That shows the negative command. Here, the first thing is rise command. The valve that comes to the downward position, that is positive command. If you give the lower command, that is upward direction, that is negative command. Here the working position of speed governing mechanism. First, the manual mode, case 1. Case 2 is also a manual mode. For the case 1, rise command we are going to give. The rise command means normally, from that rise command means that valve, the speed changer comes to downward direction. Here from the diagram, the point A comes to the downward, so that is positive. Next, point B, there is no operation in the point B. Because of that, due to the flyball sensing the speed of the governor, speed of the turbine, that only operated. If the point XA comes downward means the point normally XC goes to, that is upward position. Upward position means that is negative, because we know that that is upward means negative. So this is the rigid arrangement. If the point A downwards means if the point C goes to upward. Similarly, from the point BC, the point D is connected. If the point C goes upward means similarly the point D is also go in upward direction. So that piston, lower piston and upper piston goes to upward direction. So that oil comes to the downward position and make the piston, the valve to opening, that is comes to downward position. This is the operation of manual mode by using the rise command. Similarly, in the case 2, we are going to give the lower command. Lower command means that is negative, that is upward. If the point A goes upward means that similarly the point C come downwards. That point C is attached to the point D. If the point C, that means downward means similarly the point D is also come downwards, that makes the valve by closing the valves to turbine. This is the operation of rise command and the lower command. Here next operation mode is mechanism mode. In that mechanism mode, based upon that omega, that means speed, normally we know that is ns equal to 120 f divided by p. In that case, omega increases means that is speed increases. If the speed increases, then decreases, how the operation mechanism mode will be operated. Now for the case 3, if for position of A, that is 0, because here we are not going to change the speed changer, that so that xa is 0. Here if the xb, if the speed increases, the increases means that comes to downward position, the point B comes to downward position. Similarly, if the point B comes to downward position means the point C and D also comes to downward position. Based upon that point E, that goes to upward position. So that omega increases means we have to decrease the speed, so we have to close the valve. That is in the case of case 3. Similarly, as upon that case 4, that valve is going to open, so we have to increase the, that means steam to the turbine. This is the operation of the speed governing mechanism. Thank you.